Imagine looking into a mirror that doesn't show your reflection. Instead, it reveals a moment from billions of years ago, a time before Earth existed, before the Sun was born, before our galaxy had fully taken shape. That is the remarkable power of the James Webb Space Telescope. Unlike ordinary telescopes that simply observe distant objects, Webb allows astronomers to look back through cosmic time. Because light takes time to travel across space, every distant galaxy appears as it existed when its light first began its journey toward us. The farther Webb looks, the further back in time it sees. Its mission is not just to study stars and galaxies, but to answer one of humanity's greatest questions: how did the universe begin to build the structures we see today? According to modern cosmology, the universe began approximately 13.8 billion years ago with the Big Bang. In the earliest moments, the universe was unimaginably hot and dense. As space rapidly expanded, temperatures fell, allowing the first particles to combine into simple atoms, mostly hydrogen and helium. For millions of years afterward, there were no stars. Astronomers call this period the Cosmic Dark Ages. Although matter filled the universe, there were no shining objects to illuminate the vast darkness. Gradually, gravity began pulling enormous clouds of gas together. As these clouds became denser, the first stars ignited. Their light ended the Cosmic Dark Ages and marked the beginning of a new era. Those first stars eventually gathered into the earliest galaxies. For decades, scientists expected these ancient galaxies to be small, irregular, and relatively simple. The universe, they believed, needed hundreds of millions or even billions of years to build large, organized structures. Then the James Webb Space Telescope began sending back its observations. Instead of finding only tiny, primitive galaxies, Webb revealed objects that appeared far more developed than expected. Some showed rotating disk-like shapes. Others contained bright central regions surrounded by large populations of stars. A few even displayed surprisingly organized structures that challenged long-standing models of early galaxy formation. Naturally, astronomers questioned the results. Perhaps the distances had been measured incorrectly. Perhaps the galaxies were closer than they appeared. Scientists carefully analyzed their redshifts, the stretching of light caused by the expansion of the universe. Again and again, independent observations confirmed the same conclusion. Many of these galaxies truly existed only a few 100 million years after the Big Bang. In cosmic history, that is astonishingly early. It's similar to discovering a fully developed city where only the first foundations were expected to exist. These discoveries do not prove that our understanding of the universe is wrong. Instead, they suggest that the earliest stages of galaxy formation may have happened much faster than scientists once believed. The James Webb Space Telescope has opened an entirely new chapter in astronomy. Rather than providing simple answers, it has revealed an early universe that appears more dynamic, more active, and far more complex than anyone anticipated. And this is only the beginning. Every new observation pushes researchers to refine existing theories and search for better explanations. The deeper Webb looks into space, the more it reminds us that the universe still holds countless secrets waiting to be discovered. The surprises discovered by the James Webb Space Telescope do not end with ancient galaxies. As astronomers studied the light from these incredibly distant objects, they uncovered another remarkable clue about the early universe. Every beam of light carries a chemical fingerprint. By separating that light into its different wavelengths, scientists can identify the elements present inside distant stars and galaxies. This technique, known as spectroscopy, allows researchers to study objects billions of light-years away without ever leaving Earth. When Webb examined some of the earliest known galaxies, it detected elements such as carbon, oxygen, nitrogen, and, in some cases, iron. These heavier elements are not produced during the Big Bang itself. Instead, they are created inside stars through nuclear fusion and later scattered across space when massive stars explode as supernovae. Finding these elements in galaxies that formed only a few 100 million years after the Big Bang suggests that stars were born, evolved, and died much more rapidly than many earlier models predicted. It paints a picture of a young universe that was far more energetic than scientists once imagined. Another mystery soon emerged. Webb also identified extremely massive black holes that existed surprisingly early in cosmic history. Supermassive black holes, containing millions or even billions of times the Sun's mass, were expected to require enormous amounts of time to grow. Yet some appear to have formed much earlier than existing theories easily explain. Astronomers are exploring several possibilities. Some researchers propose that certain black holes may have formed directly from enormous collapsing clouds of gas rather than growing slowly from smaller stellar black holes. Others are investigating whether unusual conditions in the early universe accelerated their growth. At present, no single explanation has been confirmed. This is exactly how science progresses. Unexpected discoveries lead to new hypotheses, which are then tested through observation and experimentation. The James Webb Space Telescope has also expanded our understanding of interstellar chemistry. Its sensitive infrared instruments have detected complex carbon-containing molecules drifting through enormous clouds of gas and dust. These molecules are not living organisms. However, they represent important building blocks that participate in the chemistry associated with planets and, eventually, the ingredients needed for life. Their presence suggests that complex organic chemistry began very early in the universe's history. That possibility has profound implications. If the chemical ingredients for life became widespread soon after the first generations of stars, then countless planetary systems throughout the cosmos may have inherited similar materials. Whether those ingredients eventually produced life elsewhere remains one of astronomy's greatest unanswered questions. The search continues. Meanwhile, researchers are also studying the role of dark matter in shaping the earliest galaxies. Although dark matter cannot be observed directly, its gravitational influence appears essential for explaining how galaxies formed and evolved. Some new observations hint that dark matter may have helped organize matter into large structures more efficiently than scientists previously understood. Future observations will help determine whether these ideas accurately describe the young universe. One of Webb's greatest achievements is not that it has overturned modern cosmology. Instead, it has provided astronomers with extraordinary new data that allows theories to be refined and improved. Science grows stronger when new evidence challenges existing ideas. Every discovery made by Webb brings another opportunity to understand the universe with greater accuracy. Perhaps the most remarkable lesson is also the simplest. Every photon collected by the James Webb Space Telescope began its journey billions of years ago. Long before Earth formed. Long before the first oceans appeared. Long before humanity looked toward the night sky with curiosity. After traveling across unimaginable distances, that ancient light has finally reached us, carrying messages from one of the earliest chapters in cosmic history. The universe is still telling its story. And thanks to the James Webb Space Telescope, humanity has only just begun to listen.